Hello. Okay. Thanks everyone for making your time on this Saturday afternoon. My name is Firdaus. So today I'm going to be talking about the temporal workflow engine. So first off, just a little bit about myself. Um, I mostly program in Java, Kotlin, and Python. So actually, Golang isn't there. I only recently started learning Golang. If you want to get in touch with me, the easiest is through LinkedIn. I'm fortunate to own this GitHub handle. I blog at this address, at this URL. Um, I have a YouTube channel as well. I'm trying to get at least 100 subscribers so that I can get the vanity URL. So please click on this link and subscribe to my channel. Okay. If you want to email me, feel free to email me at this address. And I usually hang out at the Engineers My Slack and with this handle. The problem with talking about temporal is that temporal is a workflow engine, and everyone has their idea about what a workflow engine is. So as you can see, the space is very congested, right? There are so many projects that call themselves workflow engines. So if you've used any of these workflow engines, would you mind just mentioning in the chat Airflow or Power Automate or JPPM or JoGet, if you use any of these, so that I can get an idea of what type of workflow engines you guys are using on a regular basis. So maybe you use step function, which is quite popular these days, or maybe you've used Power Automate. Okay, so so the problem here is that when I mention the word workflow to somebody, they always have a different idea in their head. Okay, so if they're from the Airflow background, then they'll think about data pipelines. If they're from the Netflix conductor background, then they'll think about microservices orchestration. So if they are from, for example, the Microsoft, the end user automation project, they might talk about Power Automate, or they might talk about Zapier, or they might talk about Salesforce Marketing Cloud. So these are all valid workflow tools, but the problem is that everyone has some different definition, and it's difficult to have some common ground for us to explain a new workflow engine. Okay. So just for the purpose of this talk, if possible, just entertain me and use my definition of a workflow engine, okay? So my definition of a workflow engine is just a tool that helps you implement a long-running piece of business logic, okay? So just for this talk, you don't have to agree with it. Just let's use this definition, okay? Now, this brings us to the topic of temporal. Okay, so temporal is a workflow engine, and it's written in Golang. So if how many of you guys have heard of temporal? Okay, and how many of you guys have heard of Cadence, Uber Cadence? So Uber Cadence is a workflow engine that was started at Uber. What happens was that some of the founders of that project within Uber, they some of the founders of that project within Uber, they started their own company. They founded their own company, and called Temporal Technologies, and they forked the Uber Cadence source code. So this fork is actually quite important because there were some features in Uber Cadence, there are some features in Temporal that wouldn't make sense for Uber to implement, because Uber is, of course, focused on Uber use cases. So the most important being that Temporal uses a different RPC framework than Uber Cadence. So Uber Cadence uses Thrift with T-channel, and Temporal uses gRPC. So this change is actually very significant, but I'll talk to you about why it's significant later on. Okay, and I'll talk about why the fork makes sense. Okay. So with Cadence and Temporal, it's very important to explain that unlike other workflow engines, such as step functions or IFTT or Camunda, there's no DSL, there's no graphical representation. You just write the workflow in the programming language that you choose. Okay, so if you want to write a workflow in Java, there's a Java SDK. If you want to write the workflow in Golang, there's a Golang SDK, right? There's no DSL, there's no graphical tool, there's no YAML, there's no directed acyclic graph like you have in Airflow, okay? You just write your normal code using loops, control structures, object-oriented, etc. Okay. Like I said, using our definition of a workflow engine, workflows in Temporal are just long-running business logic implemented as normal programming language functions. Okay, so there's nothing special about. I mean, there's not much that is special about a function in Temporal. That is that different from a function in a normal programming language. Okay, so the caveat, of course, is that you need a supported language. You need a language that has a temporal SDK, right? The easiest way to start Cadence is, Temporal, is to download the Docker Compose file and just run Docker Compose up. So what this will do is it will start up the Temporal service. It will start up Cassandra, which is its default database, and it will also start up Temporal Web. Okay. So, so the easiest way to understand Temporal is to actually look at code. Okay. So because it is a very developer-centric tool. Okay. So unlike other tools, it's very developer-centric. So just to give you a high-level view of what components we're going to be talking about, at the center we have the Temporal service. Okay. This is written in Golang, of course. What we're going to be developing in the next few slides is we're going to be developing the worker. Okay, so the worker contains your activities and workflows. I'm going to explain what this is about in a few minutes. But your worker will contain your activities and workflows in the programming language of your choice, right? And it interfaces with the Temporal SDK using Temporal service using the SDK, right? So the SDK is what will actually be talking to the Temporal service. Okay. So later on, we'll look also at the Temporal command line tool, TCTL, and we'll look at how you can start or interface with workflows from other programs. Okay. And there's also like a web GUI for you to view workflow state and workflow history and query, etc. Okay. So just a little bit more theory before we get to the code. There are two important constructs in Temporal. Okay, when you want to define a workflow in Temporal, there are two important concepts. Okay, first is the workflow function, and the second is the activity function. Okay, so the workflow function is where you would put your business logic. Okay, so the important thing to remember is that when you write your workflow function, it should only contain state transition or coordination logic. Okay, it shouldn't touch the outside world. It should not talk to a database. It should not. It should not talk to a database directly. You should not invoke a REST API directly. Okay, calls to the database or calls to a REST API or anything that can mutate the outside world or access the outside world should always be done from an activity. So the workflow should delegate to an activity to touch the outside world. But any business rules or any business logic which is independent of that can be done in the workflow function. Okay, so it's very important to know the difference. Okay, your workflow functions will contain your business logic, and your activity functions will contain everything else. Okay, anything else that touches the outside world. Okay, so your database calls, your REST API calls. Okay. So let's look at one example of an activity. Okay, so this is our first activity. So remember, I mentioned just now, the activity function is where you should put all your code for accessing databases, REST APIs, etc. So here we have an activity function that hits a REST API, and it hits this get random cat fact API that I found, and it will return the cat fact. Okay, so as you can see, it kind of looks more or less like normal Golang code, right? It returns. In fact, in your activity code, you can have any Golang code. There are no restrictions. Okay, I'll talk about it later, but there are restrictions about what code you can put in workflow functions. But in activity functions, you can have any logic that you like. Okay. Okay, so this is it just hits a REST API, and then it returns the value of the text field return. Okay, so there's nothing much here. This is our second activity function. So this activity function will send an email. Okay, so remember, like I stated again, stated before, if you want to invoke any external services, you need to do it through an activity function. Okay, so activity functions are just plain Golang code, right? So we've gone through two activity functions. So now let's bring them together. What we're going to do here is we're going to write a workflow that fetches a cat fact, right, and sends that cat fact to somebody through an email. Okay, so this is the actual workflow function. Okay, so this is the business logic. The business logic that we want to implement is get a random cat fact and send an email. Okay, so as you can see, it kind of looks like normal Golang code, and most Golang code, you can pretty much use any Golang construct here. There are some rules, I'll talk about it later. But you need to remember that you cannot invoke the activity directly. So if you want to invoke the activity, you need to do it through this execute activity function. Okay? So here we're invoking the activity get random cat fact, and we're getting the result, the return value in this fact variable. Okay. Then we are using that, we are passing that fact variable to the send mail activity, and then our workflow is done. Okay. So so that's basically our workflow function. So just how we saw in the earlier diagram, the workflow functions and the activity functions, they live inside a worker, right? So you need to actually create the process that will host the worker, the workflow and the activity. So this is the main process that will start, that will host it. Okay. So this is the worker process. So basically, it will connect to the temporal service here. And then it will create a client, right? And it will create a client that listens to the task queue. So I'll explain this concept in a bit, but basically what happens is that workers, they will listen on a task queue, which is a queue-like structure that's exposed by the temporal service, right? And then when it gets items in the queue, the worker will delegate it to the activity or the workflow. Okay. There's a lot more to it than that, but I'll get to that later when we talk about workflow history. Okay. So here we are registering the, here we are basically registering the workflows and the activities, and then we're running it. Okay, we are starting the worker process. Okay. Okay, so now we have the worker. So let's just catch back. Let's just look at what we've done so far. We have the temporal. We've created the activities, right? We've created the workflows, right? We've integrated them with the SDK, right? We've used the SDK. Then we have created the worker as well. Okay. So so now let's look at actually invoking the workflow. Okay. So I'm kind of running out of time. So let's do this very quickly within my window. And first off, let's start the worker process. Okay. So let's do go worker, go run worker, worker.go. Okay, so now the worker is running. So as you can see, the worker is running here. Okay, so okay, so you can start your workflows using two methods. One is through the SDK, right? And the other way is through the command line tool. So let's look at doing it through using the command line tool first. Okay, so let's just do this. TCTL, workflow run, task queue, cat facts, and workflow type, random cat email. and then execution timeout 360. Okay. So what we're doing here is we're starting the workflow using the temporal command line tool, which is temporal control, or sometimes I call it TCTL. And we're specifying the task queue, which is the queue that worker listens on, and we're specifying the workflow name, which is random cat email. Okay, so let's run that. Okay, so you can see that it's running, and oh, sorry, random cat fact email. Sorry, I gave the wrong name. Should be random cat fact email. Okay. Yeah. Okay. So what you're seeing here is that as the workflow is running, we are seeing that the event log or the event history of the workflow is being recorded. Okay. So what I want to highlight here is, remember that we had two activity invocations. Remember that we had two activity invocations in our workflow, right? So as you can see, there are two activity invocations here. There's an activity invocation here, and there's also an activity invocation here. Okay. We can now get back to the slides. All right. So now let me get back to the slides. So this is the output from the worker process. This is an example of us. This is an example of us invoking the workflow from another program. So it's you just use the Golang SDK, and then you can execute the workflow like this from a Golang program. So for example, if you want to, invoke it from a REST API or from a event handler or something, you can just do it like this. Okay. So I know what you're looking at. So the logic that we're implementing is very basic. So it doesn't look very interesting yet. But what's important to keep in mind is that in temporal, if you are implementing a function that takes, for example, days or weeks or months to execute, it is just like implementing any normal function. So I know there's some lag in the comments, but would any of you guys write code like this normally in Go? You wouldn't, right? You wouldn't have a sleep for 4 hours or a sleep for 30 days in normal code. And the reason you don't do that is because the process or the machine running that process, that program, might fail, right? So if that machine or process fails, then the state of that function is gone, right? Okay. So temporal, because it stores the workflow state using event sourcing, it's always able to reproduce the state of the workflow function on another machine. Okay. So that's why we can implement code like this, which sleeps for 4 days or sleeps for 30 days, and we don't have to worry about the process or the machine dying. Because if the process or machine if the process or machine that is hosting that workflow dies, we can just start up the workflow on another machine by just replaying the state of the workflow using the workflow history. Okay. So let me just go back a little bit so that you can see what's happening. So you see that in these slides, you see that there is a log of the workflow history, right? So there's actually a little bit more information in all these. Like, for example, when you invoke the activity, the parameters, the parameters and the return values are recorded in the log as well. So it's able to replay the workflow using all that information. Okay. So I'm actually running out of time, but I have way more slides, and so I'm going to rush a little bit. This workflow function, remember I mentioned just now, activity functions can contain any logic, but workflow functions have one important requirement, and this requirement is because the temporal SDK will replay the state, the history of the workflow to get the most recent state of the workflow. So in order for this replay to work, you need to follow special rules to implement your workflow. And in particular, you need to ensure that your workflow is deterministic. Okay, so basically a deterministic algorithm is just an algorithm which, according to Wikipedia, given a particular input, will always produce the same output with the underlying machine, always passing through the same sequence of states. So what this basically means is that because your workflow will be replayed multiple times, you cannot call time.now. You need to use the now that from the workflow engine, okay? Because during replay, it will give you the previous value for the current date. So same with generating random numbers and UUIDs, right? You cannot generate random numbers or UUIDs using the default Golang functions. You need to use the temporal functions because those functions will interface with the execution history, workflow execution history, so that when they replay, you'll get the same value back. Okay. Anything else? Just do it in activity functions. You can just keep it simple. Okay. I wanted to talk about signal methods and query methods, but I think we're kind of running out of time, so I'll just cover the theory. So sometimes your workflow, it needs to communicate with the outside world, right? So for example, maybe, so imagine in the example I'm going to talk about, there's going to be, we're going to talk about a loyalty program. So in this loyalty program, based on the amount that people spend, customers are assigned a tier. So the tier is either member, silver, gold, or platinum, right? So in order for the workflow to determine the tier that the customer should be given, it needs to know the transactions that they have performed, right? So what we can do, we can model this in temporal by creating a signal method. So a signal method allows outside code to update the workflow of certain state, of certain information or certain events, right? So in our example, each time the customer does a transaction, it can update the loyalty workflow of the of that customer with that transaction. Okay, so query methods are the opposite. Query methods are a way for the outside world to query the current state of the workflow. Okay, so so these are the business rules I was talking about just now. And okay, so I know this is a Golang meetup, but I think it looks far more elegant. I know this is controversial. It looks far more elegant in Java. So the Java SDK is far more elegant. So this is the interface for the workflow. So in Java, because the Java SDK uses stubs, right? So you need to use an interface and an implementation. So this is the interface of the workflow. This is the implementation. So you see, it looks very much like normal Java code. So this here is a query method, right? So it would retrieve the current tier of the customer. This here is the signal method, okay? So outside code can invoke record transaction, and it's to let the workflow know whenever the customer perform a transaction. And this is the workflow method here, okay? So with the workflow method, it sleeps. What it does is every 30 days, it will calculate the new tier of the customer based on the transactions of the previous month, okay? So you can use the temporal command line tool to invoke signals, right? As well as to query the state of workflows. I wanted to show this in the terminal, but I think we're running out of time, so let's not do that. But basically what happens here is we're creating a workflow with a certain ID. And the reason we create it with a certain ID is because we want to have a well-known reference to that workflow so that we can give it signals and query it, okay? So here we are invoking a signal record transaction with the input 25, and here we're querying the transactions that the user has executed this month, as well as the customer's current tier. Okay. So I only scratched the surface. I basically wanted to show, during this talk, that with temporal, you can write functions like this. That means that you can write functions that can take as long as you need to run. So if you need them to run for a month, they can run for a month. If you need them to run for 12 months, for a year, for a decade, you can, okay? And you can do this without a DSL, without a DAG, or without YAML files. You just write normal code. So that is the main, in my opinion, that's the main value proposition of Cadence, right? So of temporal, okay? So around that, there are also other features that are useful in this context. There's cron workflows, child workflows. You can also have activities that take a long time to run. For example, you can have activities that start in one activity worker, but then complete in another activity worker. If you have compliance requirements, you can archive your workflow history. So workflows have a retention period, and if you pass that retention period, it's deleted. But if you want to keep it, if you want to archive it S3, it's possible. Untyped stubs are useful for, like, if you have a Java workflow that wants to communicate with a Golang activity, or vice versa. So you can use untyped stubs for that. It also supports workflow filtering, so you can assign key value attributes to your workflow, and Temporal will index this using Elasticsearch. Then you can you can filter your workflows based on those key value parameters using Elasticsearch. Okay. And namespaces, just like Kubernetes namespaces, more or less like Kubernetes namespaces. Okay. And there are a lot more. So this is basically the state of the project. Okay, so the temporal service is written in Golang. That's why I'm at this meetup. The database backends, the most mature one is Cassandra, because Cassandra is what they use at Uber, right? They also support MySQL, and PostgreSQL, I think, is in beta, right? So for search attribute support, you need to use Elasticsearch and Kafka, right? So it's optional. You don't need, if you don't need search, you don't need those two components. SDKs, all right. So in order to write workflows, temporal workflows, you need to use a language with a supported SDK. So currently there are only two SDKs supported by Temporal, a Golang SDK and a Java SDK. So the Java SDK, you can use Kotlin as well, or any other JVM languages. Cadence is an older project, so there are more SDKs. There is a Python SDK, which is written by me. There is a Ruby SDK, and there's a .NET SDK. So Cadence and Temporal, they're very similar behind the scenes, so it's only a matter of time before they get ported to Temporal. Okay. I didn't get a chance to show this, but there's a very cool web GUI for looking at the state of a workflow, and also for terminating and querying it. I think, because I don't have enough time to show it today, you can check it out when you launch the Docker Compose. You just go to this URL. Okay. This is the Temporal command line tool, right? And if you want to deploy Temporal in Kubernetes, there's a Helm chart. Okay. Okay, so I'll skip this slide, but I hope that I've driven home the fact that if you have this virtual function abstraction, right, this long-lived function abstraction, that you can use it for a lot of use cases. So that's basically what I wanted to drive home, that if you have this ability to write functions that, can take as long as you want to execute, what can you build on top of it? Okay, so the most popular thing is some type of microservice orchestration, gamification, loyalty, CI/CD. One of the most high-profile users of Cadence is actually HashiCorp, and they use it for provisioning Consul in Azure. Okay. Okay, so I just want to talk a little bit more about. If you want some resources on the internal details, or how Cadence compares to the queue and database approach, you can look at these two presentations. Okay, there's a very good Temporal talk, Temporal forum here. So if you want to ask any questions, Temporal actually guarantees that you'll get an answer. So I usually hang out in these communities. So Python SDK in the Temporal Slack group, and Python client in the Uber Cadence group. And basically my role in the Temporal and Cadence ecosystem is that I developed the Python SDK. So the Python SDK for Temporal isn't out yet, but the Cadence one is. So I'm still in the progress of porting that. And this is actually a sneak peek at how the Python SDK looks like. It's very heavily based on the Java SDK. In fact, I studied the Java SDK to figure out how to implement it in Python. That's pretty much it. I think I've covered what I could cover in 40 minutes. Sorry about that. So can we start Q&A? Do we have time for Q&A? Is there any UI dashboard to maintain the workflow? Yes. Okay, so like I said, there is no, Temporal is code-centric, okay? Temporal is a code-centric workflow engine, okay? So there is no graphical tool for authoring workflows, right? But there is a dashboard for viewing the state of workflows and for terminating workflows and for querying workflows. So it's more for troubleshooting or for, it's more for troubleshooting and for debugging, things like that, okay? So that is called Temporal Web. And when you install the Docker Compose, it will be available at port 8088, okay? How difficult is it to maintain temporal of service from an engineering perspective? Is there any? Yes, okay, so this is a good question. So temporal, so this is the good thing about the fork, okay? Because this new company that forked Uber Cadence, called Temporal Technologies, their plan is to offer a managed temporal offering, just like MongoDB Atlas, or so that we don't need to manage temporal ourselves, because I'm sure that in many companies they don't have Cassandra database DBA expertise, for example. Okay, so it's not ready yet, but a managed service will be available from Temporal Technologies sometime in the near future. Okay, because that is their main way of getting revenue. Okay. So how to handle multiple versions of the workflow when business rules changes? Okay, so this is a good question, because your workflow can take 2 months, or 2 years to run, right? So during the time, you might want to change the business logic, right? So Temporal and Cadence, they support workflow versioning. So what this means is that in the workflow code, you can query the version of the workflow, and then you can create an if to either execute the old version or the new version, okay? So if your workflow was started in the old version, you will always get the old version ID, the old version number, and you can if based on that, okay? What else do we have? Are such long-running functions very common in businesses? Okay, yes. So the problem is because we're thinking about functions, right? So if we think about programming language functions, right? Of course, we don't think about programming language functions that take years to execute, right? Because you'll get fired if we put sleep 20 days in our code, right? But if you look at business processes, if you imagine loyalty, the loyalty program, the loyalty workflow is running as long as the customer is enrolled in that loyalty program, right? So that could be 10 years, could be 20 years, or as long as they are in that loyalty program. Okay, so the difference between Cadence and Temporal and other workflow engines which you could use to model a loyalty program is that in Temporal and Cadence, you just write a normal function. Okay, so your long-running business logic is also a long-running workflow function. Okay, so so these long-running business logic exists everywhere. Okay, so like for example, Uber for example, food delivery, any type of delivery, any type of sharing economy, subscription services, for example, etc. Okay. How much time do I have left? Around 4 minutes.
Yeah, 5 minutes or so. Yeah.
5 minutes. Okay. So what else do I have here?
I think you have about.
Any more questions?
You answered most of them. In fact, all of them.
I think let's just look at the comments.
Yeah.
Okay. So meanwhile, I just have one ask. There isn't, but somebody actually implemented a step functions clone on Uber Cadence. Okay, so that's for Uber Cadence. The thing is, you can kind of think of Temporal or Cadence as a platform to build other workflow engines on top of, right? So for example, if you want to build a DSL, or if you want to build a BPNN engine, or you want to build a step functions code, or you want to build a graphical workflow engine, Temporal is a great base for doing that, okay? But it is not meant for non-programmers, okay? Right? You can build tools on top of that, like marketing automation tools, etc. But out of the box, there's nothing, okay? So I was kind of expecting a question today, but I didn't get it, because usually when Temporal and Cadence come up, people will always ask, how does this compare to Airflow, right? So I prepared for this just in case I got the question, but unfortunately I didn't get the question, which is quite good, because I hate when the two are compared together, okay? Because they're very, very different, right? So if I did not drive home that they're different, then that's why I included this slide. But if you guys are from an Airflow background, and you would want to know more about how it compares to Airflow, I'm going to do a workshop on comparing the two, because the question comes out so often in the community. So I'm going to do a workshop, and if you're interested in that workshop, just click on this link and then just submit your email address. It will be sometime in December.
When is the workshop scheduled?
Oh yeah, I'm doing it on the 16th of December. That's not confirmed yet, but I don't know whether there are enough people interested yet, but if there are, then I'll do it on the 16th of December.